In this video, you're going to learn how to solve problems involving dimension of physical quantities for your JEEs. So we're going to practice with 7 repeated questions for this topic. So let's get started with the first one I have here. Alright, so it says, which of the following is the dimension of pressure? Okay, so let's determine this. Pressure, the formula is force over area. Okay, so dimension of force is ml t to the power negative 2, alright, over area is length times breadth, or length times width, which is length square. Law of index division law, we have the length, the base is the same, so what you do, and this is dividing, we have division here. What you do now will be to subtract the power, so we're going to have ml, the power here is 1 minus 2 per pi square. Alright, so this is the same thing as ml negative 1 per time square. So the correct option to this question is what? Option D. So it's as simple as this. Let's wipe this now and solve the next repeated question. Alright, so the next repeated question will be this question. It says, which of the following is the dimension of pressure? Okay, I think we have solved this question. That was the first one we just finished solving. The correct option is option C. So let's go to the next one. So it says the values of x, y, and z respectively in the expression, this expression for the universal gravitational constant G are. Alright, so this question is actually very simple. The correct option to this question will be option A. Alright, so the gravitational constant, universal gravitational constant G, has its dimension to be m to the power negative 1 L to the power 3 and T to the power negative 2. So this is the universal gravitational constant dimension. So take note of this. This particular one oftentimes does not fail to appear in physics. So take note of this dimension of universal gravitational constant. Very important. Alright, so that's it for this question. Let's wipe this and go to the next repeated question. Alright, so the next question will be this. It says, at what respective values of x, y, and z would the units of force, the Newton, be dimensionally equivalent to this? Okay, so all you need is a dimension of force. We have force, the formula is mass times acceleration, so dimensionally to be mass times, now dimension of acceleration is velocity over time. That's basically the dimension is length per time square. So when you bring everything together, you're going to have ml t to the power negative 2. This is dimension of force. So for what we have here, the power of the m is 1, the power of the l is 1, the power of the t is negative 2. So you cannot decode the answer. The correct option is what? Option A. Alright, so that's it for this question. Let's wipe this now and solve the next repeated question. Okay, so the next repeated question will be this question. It says, which of the following dimensions represents impulse? Okay, so as we all know, the formula for impulse is force times time. So impulse equals force times time. Alright, and you know that the dimension of force is m L per time square times extra time. So when you bring everything together, you're going to have this T, the base is the same, law of indices, multiplication law, you are going to add the powers. So this will give us m L T minus 2. The power of this T here is 1 plus 1. So the final result will be m L t minus 2 plus 1 give you minus 1. Okay, so that will be the dimension of impulse for this question. So the correct option is option A. Okay, so it's as simple as this. Let's wipe this and solve the next repeated question. Okay guys, so the next repeated question we're going to solve will be this question. It says the dimension of electromotive force is, so guys take note, the dimension of electromotive force, this is another question just like universal gravitational constant dimension. Also take note of this one. For electromotive force, we have the correct dimension to be m l to the power 2 t to the power negative 3. We have current to the power negative 1. Okay, so this is the dimension of electromotive force. This is the correct one, so take note of this. This is the correct dimension of electromotive force. Very, very important. The correct option in this question is option C. Alright, so that's it. Alright, so let's wipe this now and solve the next repeated question. So the next repeated question we're going to solve will be this question. It says the expression, this expression, when a equals 1, b equals 2, and c equals negative 2 is the dimension of what? So guys, looking at this question, I can easily decode that the correct option will be option C, energy. Alright, so energy has the same dimension as work. So dimension of work equals force times distance. Okay, so dimension of force is ml t to the power negative 2 times this distance is length. So when we bring everything together, the length, we have the same base, so law of indices, you add the power, so this will give you ml 1 plus 1 t to the power negative 2. Final result will be ml to the power negative 2 per time square. So from this, our value of m, the power is 1, the L power is 2, and the T power is negative 2. So the correct option is what? Option C, which is energy. Energy has the same dimension as work. So that's it for this question. Now let's wipe this and solve the last repeated question. Let's wipe this. So the last repeated question will be this question. It says the correct unit of energy density is what? Guys, also take note of this particular question. So the correct unit of energy density is basically this option A. I'm going to show you. So energy density, let me use ED to represent it. The formula is energy over volume. Okay, so you know that energy has the same dimension as work. So basically we are going to have, I want to show you why the correct unit is kilogram per meter per second square. Okay, so energy has the same dimension as work. So the dimension of energy will be, since work is force times distance, okay, over volume is length times breadth times height. That's, we have length cube. Okay, so dimension of force is m l per time square times l over length cube. Okay, so when you simplify, you're going to have m l square per time square, okay, over l cube. A law of indices, you subtract the powers, the length, so it's division. This will give you ml 2 minus 3 per time square. So the final result will be ml to the power negative 1 per time square. Alright, so here in this question we're not dealing with dimension, so let's represent them with the standard unit. So the unit of mass is kilogram, and the unit of length measures in meter, so we have per meter, and the unit of time is seconds per second square. So that's why the correct option is option A. So it's as simple as this. This is basically how you can deal with problems involving dimensional and physical quantities for your physics. Hope you learned something interesting from this video. Let's go to the video, guys. If you are new to our channel, ensure that you subscribe to this channel for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave your question in the comment section below and I'll ensure to give you a response. Alright, now click on the screen above and I'll see you in the next video. Thanks for watching.